Yeah, hello students. So welcome back to Sri Sai Aadhan classes. It's a UAE 97156749628 and India's WhatsApp number is 9966088208. As we continue the part C about the topic called light, reflection and refraction. In the last class we have discussed regarding the concave mirrors and convex mirrors. So again a recap over here. A feature, the reflecting surface. Concave is curved inward and convex is curved outward. Nature of the image. In concave it is diverging, convex it is converging. Center of curvature of the concave mirror will be in front of the mirror, convex will be behind the mirror. Focal point in concave will be in front, convex will be rear side. Projection of the images. Images can be projected onto the screen when you are using a concave mirror. When you are using a convex mirror, you are going to get virtual images that cannot be projected. However, the image size in concave, it will be magnified, and in convex it is shrunk. Either the image is erect or inverted. Generally, in concave you are going to get inverted, except for when the object is between the pole and the focal length. Make a note. Generally inverted only, but when the object is placed between the pole and the focal length, then you will get erect. In convex, the image formed is always erect. Coming to the applications here, applications of what, sir? Why do we study this convex and concave mirror? Where do I apply here? While traveling on your bikes or in your cars, you have seen a rear view mirrors in the vehicles. That is convex mirror, which provides a wider field of view. Forms upright and virtual diminished images which helps in seeing more area, and it is used as a security mirrors in shops, parking areas and corridors. Convex mirrors are used as a security mirrors in shops, parking areas and corridors and help in reducing blind spots. Wherever there are blind spots you can find convex mirror. Then how about concave mirror? It is used in shaving mirrors and makeup mirrors. Helps in magnifying the face when the object is very clear, when the object is close. It is used by the dentist. Why? To see enlarged images of the teeth. Used in torches, searchlights and vehicles, headlights to produce a parallel beam of light. To produce a parallel beam of light, in torches, searchlight and vehicle headlights, concave mirrors are used, and it is also used in solar cookers to focus sunlight and at a point. These are the uses of concave and convex mirror. Now here another part, to go into detail we are going to discuss how to draw the ray diagram. To draw the ray diagram, my dear students, you need to follow the rules of concave mirror. So what are the rules of the concave mirror? Check the figure here properly. A part of the concave mirror we have taken. The C stands for center of curvature and F is the focus and P is the pole. So first ray which is parallel to the principal focus, and the blue color line is your principal focus. When this line is parallel to the ray of light, that is a ray of light is parallel to the principal focus, after reflection it will pass through the focus. Same scenario, incident ray, a light here, when it is parallel, if it is passing through the focus, if an incident ray line is passing, incident ray light is passing through the focus, after refraction it is parallel to the principal axis. Case 3, when a ray of light is passing through the center of curvature, it emerges back in the same direction, and the reflected ray will also pass through the center of curvature. Case 4, suppose at particular angle a ray of light is falling onto the pole. Exactly, make a note, when a ray of light is falling onto the pole, then it will reflect with the same angle. So here angle of incident and angle of reflection in of this ray of light will be the same. So these are the scenarios you can find in concave mirror, that is the rules. Now in convex mirror, so what are the 4 rules to draw a ray diagram over here? So when a ray of light is parallel to the principal axis, it emerges to be coming from the focus, passing through the focus. If a ray of light is falling onto the mirror, convex, suppose we extend it, so it is coming from the focus, so it is parallel. If it is going passing through the center of curvature, it will reflect back in the same direction. If it is passing through the pole, so the angle of incident and the angle of reflection are always the same. So these rules, my dear students, you need to follow to understand how to draw the ray diagram. Another important thing you kindly see here, make a note, that is your sign conventions of a mirror. Sign conventions of a mirror. What are the sign conventions of a mirror? You can see you have your, in mathematics, you have your Cartesian plane. In Cartesian plane, we divide the graph into four quadrants, vertical and horizontal. The vertical line and the horizontal line, they meet at a point. Suppose here that point I have taken as a mirror. That is origin. When you go towards right, the x-axis positive. When you go towards up on the y-axis, positive. When you go towards left of the graph, it is negative. When you go down to the left of the down of the graph, it is negative. So this law, these key points we will apply over here when we are drawing a ray diagrams, and regarding the signs are very important over here. If an object is placed and you are measuring the height in the upward direction, going up is positive, coming back is negative. Going down, measuring the height of the object image, down is negative, going towards the right side is positive. Both in concave and convex mirror. These rules to be followed. Make a note, have a look regarding how you divide the Cartesian plane. Now after that, students, here you measure always. All the distances are measured from the pole of the mirror as the origin. From pole will be the origin. From the pole only you will start measuring the distances. The distance measured in the direction of the incident ray. In this direction I am measuring. So this direction is positive. If the distances are measured in the opposite direction, this is the image form. So from I am going back, so it will be taken as a negative. Distances measured in the upward direction and are perpendicular to the principal axis are positive. Distances measured in the downward direction and are perpendicular are taken as a negative. Here you have one formula, 1 over f is equal to 1 over v plus 1 over u. 1 over f will be is equal to 1 over f is equal to 1 over v plus 1 over u, for where f, v and u are focal length, image distance and object distance. Next comes the topic called linear magnification. What is linear magnification? The linear magnification M of a mirror, which will measure how much larger or smaller an image is compared to the object. When you got an object, definitely when you are placing in front of the mirror, you are going to find the image. So is this image larger or smaller, that we are going to compare and measure and find it out. So it is defined as the image ratio, it is defined as the ratios of image height h dash to the object height h dash over h, or it can also be calculated as object distance is u and image distance is v. So see here the formula of linear magnification. M is equal to height of image over height of object, h dash over h, or h dash over h, or negative v over u. And these are the key points over here regarding the image orientation. A positive magnification, when your magnification will be positive when it is greater than 0. If it is greater than 0, it is positive and it will indicate the image is virtual and erect. How the image is? The image is virtual and erect. And negative magnification means it will be less than 0. M will be less than 0 and it will indicate a real and an inverted image. It indicates a real and an inverted image. Regarding the size, M is greater than 0, the image is magnified, larger than the object. M is less than 0, image is diminished. Smaller than the object, m is equal to 1, the image is exactly the same size as the object. Then how about the plane mirrors here? What will happen? In plane mirrors, they will produce virtual erect images of the same size, meaning m is exactly equal to plus 1. In convex, always virtual, erect and diminished, meaning m value will lie in between 0 and plus 1. In concave, it can produce both real and virtual images of different sizes. So m can be either positive or negative real numbers. So this is about entire how to know about the concave and convex mirrors, my dear students. Any doubts, any queries, you have the number. You can WhatsApp or you can send uh, notification in the YouTube channel. We have our YouTube channel, Sri Sai Aadhan Classes, Rajesh Pupala. Thank you so much and good day. Meet you with the part 4 students.